Okay, right now we're going to learn how to determine an empirical formula. An empirical formula is the lowest whole number ratio of atoms in a molecule. And so if you're given the mass of each element in grams, you want to convert that into moles because the empirical formula is a mole ratio or a particle ratio, not a mass ratio. So the first step is always going to be to convert from mass to moles. And then we want to determine the lowest whole number ratio. The easiest way to do that is usually by dividing by the smallest value. If you divide everything by the same value, you're not changing the ratio, and this just helps us get it into a whole number. All right, so in my example here, I have a sample that's 80 grams of carbon and 20 grams of hydrogen, and I want to try to figure out what the formula of this compound is. So to do this, I take 80 grams of carbon, and I want to change that into moles. So to change grams of carbon into moles of carbon, we use the molar mass of carbon. So you find carbon on the periodic table, and the molar mass of carbon is 12 grams per mole. So I'd put 12 grams of carbon on the bottom, 1 mole of carbon on the top. So you do 80 divided by 12, and when you do that, you get 6.66 moles of carbon. Now we do the same thing with the hydrogen. So in our sample we have 20 grams of hydrogen. Molar mass of hydrogen, when you look it up on the periodic table, is 1 gram of hydrogen for every 1 mole. So the grams cancel out, and you get 20 moles of hydrogen. So that's the first step. We were given the mass, and we converted from grams into moles using molar mass from the periodic table. Now the second step is to find the ratio between these things. So when we write out the formula, we want it to be whole numbers. And so we're going to divide by the smaller of these two numbers. 6.66 is smaller than 20, so we'll divide them both by 6.66. And when you do that, you get 1 mole of carbon, and you get 3 moles of hydrogen. If this doesn't come out to be exactly 3, if it comes out to be 2.99 or 3.01, you can usually round it off to the nearest whole number. So our ratio is 1 mole of carbon to 3 moles of hydrogen. So when we write out our formula, it would be CH3. And so that's the empirical formula for this compound. We'll do one more example. So this example will be a little bit different. This time, instead of being given the mass of each substance, we're given it in percentages. So it says a compound is 15.6% calcium, 40.6% chromium, and 43.7% oxygen. What's the empirical formula? So we're going to do the same 2 steps that we did here. We're going to convert everything into moles, and then we're going to divide by the smallest number to get the ratio. The difference here is that we're given percentages. So when you're given percentages, we're just going to pretend we have a 100-gram sample to make our calculations easy. If you had a 100-gram sample and 15.6% of it was calcium, then you would have 15.6 grams of calcium. You'd also have 40.6 grams of chromium, and you'd have 43.7 grams of oxygen. So I'm just going to assume that I have a 100-gram sample, and then I'm going to take all my percentages and change them into grams. The next step is to change grams to moles. So to do this, we're going to use the molar mass. So we look at our periodic table. We find calcium on the periodic table. It has a molar mass of 40 grams per mole. So 40 grams of calcium for every 1 mole. For chromium, we find its molar mass, and the molar mass of chromium is 52 grams of chromium for every 1 mole of chromium. And for oxygen, 16 grams of oxygen for every mole of oxygen. So these are molar masses from the periodic table, allowing us to change from grams to moles. So for the calcium, you get 0.39 moles of calcium. For the chromium, We got 0.78 moles of chromium. And then for the oxygen, you got 2.73 moles of oxygen. So we converted everything from grams to moles. That was our first step when we looked at the general steps.
May attention please, Charles Swinburne, report to the Dean's office immediately.
So you change everything from grams to moles first. And the second step is to get the whole number ratio. So we're going to look at these numbers, 0.39, 0.78, and 2.73. Find the smallest one. So that's 0.39, 0.39, 0.39. So we're not changing the ratio, we're just dividing them all by the same number, so the ratio stays the same. And when we do this, we get 1 mole of calcium. You get 2 moles of chromium. And you get 7 moles of oxygen. So our ratio is 1 to 2 to 7. So when I write out the formula, it's CaCr2O7. So it's a 1 to 2 to 7 ratio. And we found that ratio by changing grams to moles and then dividing all the moles by the smallest number to find the lowest whole number ratio.